Hello again, this is Dr. Ali El-Bahrawy, and this session is devoted to examples from different sources of some people who designed their graphs, and I have serious comments on the message sent by graphs. I will go through different examples and discuss with you what's wrong with the graphs. I attend a lot of conferences, and sometimes I couldn't prevent myself from having a screenshot of the presentation. Here in this slide, he wants to show the percent of total irrigated area in a geographical location. Where you add these percentages, they come up to 100. Therefore, they are parts of a whole, and the best graphic presentation is a pie chart. In this, he uses really pie chart, but the numbers in the pie charts cannot be added together because they are specific water demand numbers. They cannot be added together, and because it's a simple comparison, a better graph is to use column graph just for simple comparison. In this slide, he shows the total population and the population served and the population unserved for rural and urban areas. I don't see any reason for putting the total here. And actually the use of clustered column is not good. My suggestion is to use only two series. One of them clustered column for rural and the other one is clustered column for urban, and it will give you the ratio and the total without using the third series. National report, this is a national report about education, and you can see that the graph is cluttered because the percentages are shown here. We should not show the percentages. And another interesting thing is that this is a timeline. Therefore, we like to see the trend. Therefore, the clustered column is not suitable. I would have preferred an area chart, because if we add this number to this number to this number, in the three cases they come up with 100. Therefore, if you see percentages, please add them. If they are in 100 and the presentation is not stacked column or stacked bar or pie chart, you have to change the type of graph. This also shows a timeline. I prefer the timeline to appear on the x-axis, and the percentages will appear as lines to see what happens with time for 5 data series for public universities, Azhar University, private universities, higher private universities, and technical colleges. In this graph, they are calculating the faculty, assistant, staff numbers. But look, the number shown on the y-axis is a denominator. It is this number here. Therefore, 1 over 1.19 should not be written, because what we read here is 1.19. Therefore, we have to have a proper y-axis, remove the data labels, and also sort the data, because we want to know the education institution with the highest faculty member assistant staff ratio. Here, if we add the percentages, they come up to 100. Therefore, the best way is to use stacked column, and of course remove the data labels because they are written in a different number format, and they are making the graph cluttered. Now you get my point. For technical papers, this is a person here or a researcher who likes to compare traditional method with proposed system for different geographical location or plants, and I don't find joining the markers a good idea, because this is not a trend with time or distance. And my suggestion to this person is to use a clustered column to compare between this value and this value for each of these geographical plants. This is also another researcher comparing the values of pH value along the I think Rosetta branch using certain locations, kilometers, and this is a trend with distance. Therefore, we remove the columns and we have three XY scattered lines. Why? Because the distances between the kilometrage is not the same. I cannot use a line graph because the distance between 8.1 and 10.8 different from the distance between 10.8 and 25.8. He is using a clustered column. Of course, we have to remove the data labels because they are not readable, and because this is a timeline, we can use a line graph, and we cannot add these two values together because they are not addable. Why? Because one of them reports to drainage reuse and the bigger one mentions the outflow to the Mediterranean Sea. They cannot be added together. Therefore, my suggestion is to use a line graph if the distances between the dates are the same. If not, we use date format and let the computer does the automatic scaling as it pleases. Some regional reports, like reporting situation in the Arab region. This is the area of the Arab region after subtracting South Sudan after independence. And this graph shows the annual precipitation, or the annual precipitation one time expressed as depth in millimeter and the other time in volume by multiplying the depths by area. Look here, every time the report mentions or compares the 22 different countries, he uses sorting. But if you sort, you don't know where the country is, because in the first graph, according to millimeter, Comoros, Lebanon, Morocco are the first three. For the same data, but using different item for comparing, we get Sudan, Somalia, and Morocco. But you mean the sorting differs because the value, of course, the numerical value is different. Therefore, it is very difficult for me to follow what's happening because every time the location of the country changes its position because of the sorting. How to solve this problem? I will have my suggestion by the end of this. This is also shows the annual total number of floods and the total number of deaths. Look here that the number of floods cannot compare because they are all close to the x-axis. In order to read them properly, we have to choose a secondary y-axis so that we have a separate axis for the annual number of floods and another axis for the total number of deaths, as I have shown you in the previous session. This is also a cluttered pie chart because the number of slices or wedges are too many. My suggestion for this is to use a stacked bar chart. It will be much more readable. This one I'm showing you because of the importance of this. This graph shows us that the Arab countries, especially Egypt, Algeria, Saudi Arabia, and some important other Arab countries, they are importing a lot of food. Virtual water here means the water used to produce the food, because we eat cereals, we eat vegetables and fruits and meat and chicken, and all these products needs water. Therefore, importing this agricultural or food product, it's like importing virtual water. It's an important fact about the area we live in. Here, it's adding the ratio of internal and external renewable water resources. It uses percentages, they add up to 100. My suggestion does not tell us the relative values of water resources in each of the countries. I would use, if I am the one drawing this, a stacked column chart with the actual values. It will show us the percentage, and on top of that, it will tell us the amount of water values for each country. My suggestion to improve the graph at the beginning of the session is to put the graphs on a map if we have a software like Geographic Information System or another available sources. Some of them are open source. Or to cluster the Arab regions and report on each cluster separately. My suggestion for clustering is this. I will use part of the North Africa, including Libya, Tunisia, Algeria, and Morocco and Mauritania. I use Egypt, Sudan, and Somalia in one cluster, and then the Gulf countries in one cluster, and El-Sham or Syria, Iraq, Jordan, and Lebanon, and Palestine in one cluster. In general, before ending this session, every time you see a paragraph like that with a lot of numbers, the message is hidden inside the paragraph. The reader cannot really know the message if I keep the information in the paragraph. One intermediate step is to put this in a table. This table will include enrollment percentage for these years in Cairo, North Valley, and South Valley. In the paragraph, they also report the number of institutes. This could be a good solution, but a better solution is to plot them, and this is how I plotted them. I cannot put them in the same graph because they are not related. Therefore, I created two graphs. Again, this is simple comparison, and I, of course, sorted the data. Here, I cannot read the differences here because of the small scale. There is a trick. I can use logarithmic scale so that I can read this. Let us go to the spreadsheet and see how we can do this. This is, I go here, I click that, and then I go to data format axis, and I use logarithmic scale. If I do logarithmic scale, you can see the differences now. I like to draw your attention that this number is 3.06. It looks as 5 here, but because the gradation between 1 and 10 are not the same increment for every, going from 1 to 2 is different from going from 2 to 3 because it's a logarithmic scale. In order to make this clearer, you can ask the computer to put the grid lines, horizontal, minor grid lines, and this way you can have a better way of reading the numbers. My last slide is my own famous quote. All what I explained to you so far is very important to your career, and it's very important to yourself. Why? Because every time you write a paragraph, you put numbers in a table or convert data into a graph, you are sending a part of yourself without knowing. But if you speak about these graphs, you yourself become a part of the message also without knowing. So my advice is, please be careful. Again, I will end with a musical break, but this time is a surprise. It's Mr. Beethoven himself. You are going to listen to Symphony number 3 called Eroica, and it will take only 2 minutes and 21 seconds. Enjoy the information and enjoy the music.